This video is going to help you remember a few essential skills from Algebra 1. These are skills that we're going to be using almost every single day in class, so it's very important that you have a sufficient mastery of them. First off, we have linear equations. These are your very basic equations that you first started working with when you were first introduced to algebra. Linear equations can be solved using your four basic operations: addition, subtraction, multiplication, and division. I won't walk through solving all of these examples here since you should be able to solve them without much difficulty, but here's a quick breakdown. In equation 1, we can solve this by adding 9 to both sides and then dividing both sides by 5. You should get x equals 6. In equation 2, I would recommend subtracting 1 on both sides, then multiplying both sides by 4, adding 3 to both sides, and then you should get x equals a 7. On equation number 3 here, you could either distribute the 5 in, and you'd get 5x plus 10 equals 25. Subtracting 10 from both sides gets you 5x equals 25. And then when you divide by 5, you get x equals 3. One other approach you could take to this equation is you could have first divided both sides by 5 and then subtracted 2 from both sides, which is actually a little bit easier. Doesn't matter though, as long as you can get to x equals 3, you're good. Next, we have linear systems of equations. These are a bit trickier since we have more than one equation and more than one variable. The solution to any system of equations should be values of every single variable that solve all of the equations. There are 3 ways to solve linear systems. The first is graphing, and you pretty much just graph 2 lines and see where they meet. In this example, you could graph both lines. Just take a look at the slope and the y-intercept of each of them. It really looks like 1, negative 1 is the solution to this system of equations. You could plug in 1 for x, negative 1 for y, and you're actually going to get a true statement for both equations, meaning that's our solution since it solves both equations. Now this is a nice visual technique, however it's not the most reliable. It pretty much only works for us whenever our answers are all whole numbers, and that's not always going to be the case. There's no guarantee that we're going to get whole numbers for all of our answers. For example, let's say that our y value was 0.437. That's kind of tricky to see on a number line, and it's also kind of tricky to see in the xy plane. So the next more reliable method that we're going to use is called substitution. The basic idea of substitution is we're going to pick one equation and solve for one variable in that equation, and then once we get our answer, we'll plug that into the other equation. In this example here, it seems easiest to solve the bottom equation for x because you can do that in one single step. If you do solve for x, we get x equals 5 minus 2y. We're going to plug that into the other equation, and then from here this is just a linear equation and we get y equals 2. So you can plug this y equals 2 into any equation that you want. I decided to plug it into the one that I solved earlier for x. It just turned out to be pretty simple to solve from there, and I get x equals a 1. So our solution, when we state it, is going to be 1, 2 in parentheses. Now, the last way to solve systems of equations is going to be called elimination. Some people call this linear combination. It's really the same thing. The basic idea here is we want to add the equations in such a way that one of our variables is eliminated. So in this example, notice that if we do add the equations as is, we run into a problem because neither one of my variables, x or y, neither one cancels. So frowny face. What we might need to do is multiply or divide one or both of these equations by something in order to cancel all of the x's and or all of the y's. So I'm noticing that my y terms have opposite signs, and if they had the same coefficient but opposite signs, then they would cancel. So what I could do is take that bottom equation and multiply by positive 3. So that's how we get the 6x, the minus 3y, and then 3 times 0 still gives us 0. Now when we add the equations how they are here, the y's will cancel, and seems like we can solve this one equation for x. Looks like we get 0. Then we can go back in and plug to any equation we want to, say like that first one, and we get y also equals 0. Kind of a coincidence. Doesn't always give you both zeros. Could be a 0 and a 5 for all we know. But that is our solution to this system of equations. The last kind of equation from Algebra 1 that you should be comfortable solving is called quadratic. So quadratic equations always can be written in this form: ax squared plus bx plus c equals 0, where a, b, and c are just constants. So the three ways to solve are going to be factoring. It's relatively quick but doesn't always work. Quadratic formula. This does always work but can be kind of annoying and take some time. Or taking square roots, but this really only works when b is a 0. So looking at two quick examples here, this first one, b is 0. There's no x term. So what I could do is just divide both sides by 5 and then take square roots. If you did that, you might think, ooh, I get a 4. And you are correct. However, make sure that you also get negative 4. When you take square roots on both sides, you always have to consider the positive and negative versions of those. In the second equation, b is not a 0. b is a negative 3. So I'm going to try factoring first, because if it works pretty quickly. The trick to factoring, and I usually factor when a is a 1. There are ways to factor when a is a different number than 1, but it's usually quickest when a is a 1, and that's the case here. We want to look at factors of c that add up to b. So we want factors of positive 2 that add up to negative 3. And we want to rewrite this adding, or this summation, as a product, where there's a product on the left-hand side and a 0 on the right-hand side. So two numbers that multiply to positive 2 and add to minus 3, those two numbers would be negative 1 and negative 2. So I can write them in these parentheses here, and now I have a product. Two things are multiplying and I get 0. That means I must have multiplied by 0 itself. So this first factor, I want to find out where that's 0. That's going to be where x equals a 1. And the second factor will be 0 when x equals 2. So those are going to be my two solutions. Now, if I didn't use factoring, I could use quadratic formula, which you should all know by heart, right here. You want to identify a, b, and c, and then just plug them into the right spot. So here a is 1, b is negative 3, c is 2. And then, as I mentioned, it's kind of annoying. From here, there's a lot of simplifying you have to do. So you should get 3, give or take, the square root of 9 minus 8. And 9 minus 8 is a 1. The square root of 1 is just a 1. So that's really the same as 3, give or take 1, all divided by 2. If you add a 1 to 3 and then divide by 2, you get a 2. If you subtract a 1 from 3 and then divide by 2, you get a 1. So that's it for Algebra Review.